How do you prove similar triangles? Using postulates and theorems. This is for Chapter 7, Section 3 out of your textbooks, and we're going to answer this question by the end of the video. Here's an example of how your notes should look to take notes from this video. In Unit 1, we discussed when two triangles are congruent and the statements to use to prove that the triangles are congruent. And then for this new unit, Unit 2, we've been discussing how to use similarity ratios and how to determine if two figures are similar. Well, now we're going to be able to prove whether two triangles are similar, and we're going to be using some of the similar statements that we have discussed when we discussed congruent triangles. So here's our first one that we're going to mention. It's the AA similarity. This is for angle and angle. If two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. Let's assume that that third angle will also be congruent. And remember, two triangles being similar will have the same angle measurement, but their sides will be proportional to each other. So we're given that angle A is congruent to angle D, and we're given that angle B is congruent to angle E. Therefore, by angle, triangle ABC is congruent to triangle DEF. Make sure you get all the information on the slide in your notes. Here's our next similarity statement, side-side similarity. If the measures of the corresponding sides of two triangles are proportional, then the triangles are similar. And that follows with the definition of similar triangles. And let's see what was given to us. We have AB, this side here, over DE. So that's going to be 5 over 10. And if I reduce that, I get 1/2. Let me write that so you can see it. So this is 5 over 10. If I reduce it, I get 1/2. Is equal to BC over EF, which is the same proportional ratio. If I look at 8 over 16 and I reduce, I will get 1/2. And the same thing goes for side AC to DF, which is 11 over 22, and reduced will be 1/2. Because all sides are proportional, and I should write that right down here, equals 1/2, then our conclusion is to say that triangle ABC is similar to triangle DEF by side similarity. Here is our next similarity statement. It's actually a postulate or theorem. Some of them are postulates, some of them are theorems, but that's not important. We're learning what we can use to determine if two triangles are similar. And you could use side similarity. If the measures of two sides of a triangle are proportional to the measures of two corresponding sides of another triangle, and the angle between them are congruent, that is what we call the the included angle. So what they mean by that is the included angle. Remember, we discussed included angles when we were discussing congruent triangles. Then the triangles are similar. So in this case, what's given to us is that angle A is congruent to angle D, and AB over DE is proportional to AC over DF. And notice that the angle is included between the two sides that we are doing proportional relationships to. They both reduce to 1/2, therefore triangle ABC is similar to triangle DEF. And now we're going to begin working on some proofs. We're going to be proving triangles similar. Similarity is reflexive, symmetric, and transitive. And if you forgot what these three terms were, look back in your notes because we have discussed what each of these terms are used for. So the steps for proving triangles similar is 3 steps. You need to mark the given in your triangles. Always do that. This is a very important step. I'll put a star next to it. Do that in your notes. Then you're going to mark shared angles or vertical angles. And by shared angles, we're talking about angle pairs like the alternate interior angles or corresponding angles or alternate exterior angles. And then choose a method, either angle, angle, side, 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 or side, angle, side. Think about what you need for the chosen method and be sure to include those parts in your proof. So these are the 3 steps that we're going to follow along for the next couple of proofs. I'm going to go ahead and give you some time to write down this information and then play it when you're ready to follow along with the lesson. Okay, here's problem number 1. Go ahead and pause the video, write down everything that you see on here, and then I'll go ahead and discuss it and be ready to follow along and add some extra pieces to your notes. Okay, I'll assume that you paused the video and you wrote down the information. This is problem number 1. We are given that DE is parallel to FG, and we notated that by these triangles here. This one's a little bit off, but we're saying that DE is congruent to FG. We're going to prove that this triangle is similar to this triangle. So let's mark the given and what it implies. So we marked that these 2 sides are parallel. And since they're parallel, we then can see that this angle D is congruent to angle F, and angle G would be congruent to angle E, and also angle C right here and here are congruent to each other. Those are the vertical angles and also the angle pairs. Remember the 2 parallel lines and the transversal? Okay, there's one here and one here. Now we're going to mark the vertical angles, which we did. And then we're going to choose a method. I think angle is the best to use for this because we cannot see that any sides are proportional to each other. Then we're going to list the parts and order the method with reasons. So now this is what's given to us. DE was parallel to FG. We want to start with that. Then we know that since they have parallel sides, then angle D is congruent to angle F by alternate interior angles. Angle E is congruent to angle G by alternate interior angles. And now that we've proven that 2 angles are congruent to each other from both triangles, by angle, these 2 triangles are similar to each other. So I did that a little bit quickly. If you want, rewind the video, go back to when I start to talk about problem number 1, and then replay what I've said. We didn't need to add too much to the notes already because we already marked our picture. But make sure you have the steps written down, and this is our statements, reasons, proofs. And we'll be practicing this in class. Okay, take a minute to go ahead and write down problem number 2 in your notes. And then when you're ready to follow along with me, go ahead and play the video. Okay, I'll assume that you're ready to follow along with what I'm saying on this problem, and that you have this problem written down, everything written down in your notes. We're given that IJ is equal to 3LN, and JK is equal to 3NP, and IK is equal to 3LP. So we're going to mark the given and what it implies. What it implies is that the ratios are all going to be equal to each other. So if this side is 3, it's going to be over 1. This side is 3, it'll be proportional to the 1. And this side is proportional to this side by 3. And then we need to choose a method. Now, since we're talking about only the sides and we're not talking about any included angles on what's given to me, I'm going to use side, side, side. And I kind of discussed why we chose side, side, side. So let's list the parts in order of the method with the reasons. So we were given this information right here. Then if we divide both sides by ln here for this expression, if we divide both sides by np here for this expression, and if you divide both sides by lp here for this expression, we can see that each ratio is going to equal to 3. And that's by the division property. Then by substitution, I can just take out the 3's and set these 3 ratios equal to each other. And therefore, these ratios create a proportion that is equal to each other. So this is an equivalent proportion. And therefore, IJK is similar to LNP by the side-side-side similarity. Okay, here's our last problem, number 3. I'm actually going to highlight this problem with you, and then I'm going to give you the answer on the next slide, which is a two-sided proof. But I'd like you to challenge yourself. Go ahead and write down everything you see here, and then when you're ready to follow along with me, resume the video. Okay, I will assume that you wrote down everything in your notes and ready to follow along. So we're given that G is the midpoint of ED, G is the midpoint of ED, and H is the midpoint of EF. And we're trying to prove that this large triangle, which is the blue one here, is similar to the smaller triangle, which is the red one here. I think it actually kind of goes backward. Is the red one is first, which is a smaller triangle, is similar to the larger triangle, which is the blue one here. So I marked the given and what it applies. Since G is the midpoint of this side and H is the midpoint of this side, if I separate the two triangles, the blue one, which is the larger one, and the red one, which is the smaller one, I can see that the sides are proportional to each other. 2 over 1 is the same thing as 4 over 2, which is reduced to 2 over 1. And their included angle of the two sides is also congruent. Oops, let me reverse that or erase it. It should only be one marking. Notice they share the same angle of E. It's notated there and notated there. So by side, angle, side, these two triangles are similar to each other. Is there any more that you could think of to help prove that? And I'd like you to try to do the two-column proof on your own with statements and reasons. And then when you're ready to check your answer, go ahead and play the video and I will give you the answer on the next slide. Okay, go ahead and check to see if your proof was correct. And here you can see the statements that I discussed and also the reasons that I gave to figure out that the two triangles are similar to each other by side, angle, side postulate. Bring any questions that you have to class and we'll discuss this proof together tomorrow.